Basic Sevens, and Mrs. Morrissey here. This week's math is going to be a bit of an area review, and there'll be some pieces of it that kind of bring us back into algebra, especially when we're finding our missing equation. The slideshow that we have for today is a mixture of pages for you to work on and informational pages. So you know it's an information page where there's normally a question, it has the formula, and it shows you quickly how to work through the questions. You don't need to do anything on them, you just need to read them and remember. You know that the page that you need to work on are the ones that have an orangey red square on them, or rectangle on them, and it normally says show your work. And that's where you are going to answer the questions. If there is a page that does not have a red and orange square on it, then it's just an informational page. If it does have a red orange square on it, then this is a page that you need to work on for sure. The first concept that we're looking at in this package is the area of rectangles. So we'll take a standard looking rectangle like this, and let's label the sides. 4 centimeters and 3 centimeters. Now, area always deals with the amount of space that is inside your shape. Right? If I wanted to do perimeter, it would be the distance around the outside of the shape. But area is always the inside of the shape. For a rectangle, our formula is A equals length times width. And if we go back to our original shape, we have a length and we have a width. So easy enough. The formula is always the first line of our solution. The second line of our solution always has an equal sign lined up underneath. And then for the second line, we always plug in the numbers. So in this case, we have a 4 in our length times a 3 in our width. Our third line of our solution has the equal signs all lined up. And we just simply need to write the answer. And then we need to go back with a measurement squared. And your length times width formula here will work well on rectangles, and it'll work on squares. So that should be easy enough to follow along. And that should be a review for everyone. Our next shape that we're going to deal with are parallelograms. Parallelograms, you know, 6/7s are what I call a rectangle that an elephant sat on. Right? It has 2 equal angles here, it has 2 equal angles here, and it has 2 sets of parallel lines. All right, so when we're looking for the area of a parallelogram, the formula that we need to worry about is area equals base, which is the flat piece that it sits on, times the height. And the only thing you really need to remember about the height is that it needs to be not the diagonal line here, but in fact it needs to be a straight uppy-downy line that is perpendicular to the base, because we know that diagonal lines are longer than straight uppy-downy lines. And so we need the straight. So in this case, if my base is 12 centimeters and my straight uppy-downy is 5 centimeters, my diagonal is probably 6 centimeters. Now, if I was using perimeter, I would need my 6 centimeter diagonal line. But for area, I only need the base and the straight uppy-downy perpendicular line. So here's my formula out for my first line of my solution. The second step of my solution is to plug in the numbers. My base is 12. My height is 5. My third step, notice the equal signs all neatly down in a row, and notice each of my steps are also going down in a row and not across the page. I put my answer, and then I go back up to my question and I see my measurement and my squared, because we're dealing with 2 dimensions here. Again, this should be review. This should not be frightening or scary to anybody. Not yet. Now, where it gets into algebra is when we're looking at a question where a piece is missing. So, for example, a piece of our information is going to be missing off this parallelogram. Okay? We're going to have a base of 10 centimeters. We're going to have our perpendicular line, we're going to have our diagonal line at 4 centimeters, but we don't know how long our perpendicular line is, our height is. We do know, however, that the whole area is 30 centimeters squared. All right, our whole area is 30 centimeters squared. So now what we're going to do is we're going to set up our formula, base times height. Our second step is going to look a little bit different because for our second step, we're going to plug in what we know. And in this case, we actually know the area. We know the answer, which is a bit strange. So we're going to put that in there. Our base is 10, so we're going to put in that, multiplied by, we don't want this diagonal here, we want this straight uppy downy line. And we don't know it, it's a question mark. So I'm just going to leave it as an H. All right. Now, if you think back to your algebra days, if I want to get H by itself, I want to get the unknown by itself, the best way to do that is to get rid of the times 10. And we know to get rid of times 10, you need to divide by 10. And in order to make it fair, what you do to this side, you need to do to this side. All right? Now, my times 10 divided by 10 actually negate or cross each other out, and we're just left with H. The math on this side is 30 divided by 10, which is 3, and we now have an answer of 3 equals H. So now I know that my whole area is 30, my base is 10, and my missing answer is 3. Okay, let's do one more just because that is kind of a trickier concept. All right, so here's my parallelogram. I know that the whole area is 24 centimeters squared. I know that my base right here, my bottom piece right here, is 4 centimeters, but I don't know what my height is. I have no idea. It's not listed. So I'm going to solve it, and I want to solve for my H because I don't know what it is. So the first thing I do is I put in my formula, base times height. I plug in what I know. In this case, I know the area is 24. I know the base is 4, but I don't know the height. So I'm just going to leave it as an H. And again, if we go back to our algebra and we remember that we want to get H by itself, the best way to get H by itself is to get rid of this times 4. The best way to get rid of times 4 is to divide it by 4. And what I do to one side, in order to make it equal on this side, I have to do the same thing over here. So now, my times 4 divided by 4 cross each other out, and I'm left with H on this side. And over here, 24 divided by 4 is 6. And if I go back up here, I can plug my 6 into my unknown. So that's sort of the trickiest part, is trying to find those unknowns. Our next shape is a triangle. For a triangle, our formula is area equals base times height divided by 2. You sometimes see it as in area equals base times height divided by 2. It looks like I'm setting up a fraction, but it is actually a division sign. So I like to do it this way though, but you may see it in other situations the other way. So in this case, just like our parallelogram, we don't want to use our diagonal lines. We want to use our straight uppy downy lines and our base. So in this case, our base is going to be 10 centimeters. All right. Our uppy downy here is going to be 12 centimeters. We don't want to use those diagonal lines again because the diagonal lines are longer than our straight up and down. So we're going to plug in our numbers. Again, notice my equal signs are going to be nice and straight coming down. My second line, after I've put on the formula, is always going to be plugging in the numbers. So my base is 10. My height is 12, and part of the formula says I have to divide by 2. If we look at bed mass, I can do my multiplication and division in order. So I'm going to do 10 times 12, which is 120, divided by 2, because I haven't done that yet. And 120 divided by 2 is 60 centimeters squared. I could skip this third step right here, and I could do 10 times 2 in my head, remember 120, divided by 2 and get 60, and I'd be okay with that, as long as I still had 3 steps along the way. Okay, let's do one more triangle. Okay, so sometimes our triangles look like this. They are right angle triangles. And they're actually very helpful because 2 of our lines already meet at a perpendicular angle. So let's say that this one is 6 meters long and this side is 5 meters long. And I don't have to worry about using this side because I've already got it here at the perpendicular. So my formula is going to be A equals base times height divided by 2. All I simply do is plug in the numbers. My base is 6, my height is 5, and I divide by 2. I do the multiplication. I'm going to do it all in one step this time and save myself the fourth step. So 6 times 5 is 30. 30 divided by 2 is 15. So my answer is going to be 15 meters. Go back to my measurement there with our floating 2 for squared. Now sometimes we can have the same problem happen where we have some of the information but we are missing a key piece of it. So your slides gives you the example of this triangle where we have a base of 8 centimeters. We don't know the height this time, but we know that the whole area is 20. So we want to figure out what is this missing side. And as soon as we're talking about an unknown side, this is algebra, and we can definitely work through this. So the first thing we want to do is set up our formula, base times height divided by 2. The next thing we want to do is plug in what we have. So we have the area, so it's going to go on this side. We have the base, which is 8, so it's going to go here. We don't have the height, so I'm going to leave it as a height. And the formula tells us we need to divide by 2, so we're going to divide by 2. Okay? Now, I want to get h by itself, but this divided by 2 is kind of bothersome. So the first thing I'm going to do is I'm going to take, in order to get rid of this divide by 2, I'm actually going to times by 2 on this side and times by 2 on this side. And this is going to get me 40 on this side. And I didn't do anything with that 8 times h, so I'm going to leave it there. And my divided by 2 and my times 2 cross each other out. So now all I have left is 40 equals 8 times h. But h isn't still by itself yet. So I want to get rid of this times 8. And the only way to get rid of my times 8 is to divide by 8. I can divide by 8 on this side as well, because I have to do the same thing on both sides of the equal sign. And let me just move it down so you can see it. There we go. This crosses each other out. I'm left with h on this side, and 40 divided by 8 is 5 on this side. It's a little bit trickier finding the unknown when you have a triangle, but it is actually kind of fun and a little bit of the algebra that we worked on a couple of weeks ago. Okay, so then there are some multiple choice questions, and they're easy enough, but they're a little bit tricky because they give you word problems, but they don't actually show you the picture. So you've got to sort of figure out in your head, what does the triangle and the parallelogram look like? So there's a couple of those. The very last thing is a trapezoid. So a trapezoid looks like this. I always call it, it's like kind of like the lion tamer stand, right? The lion stands up here on this little trapezoid. This is for grade 7s technically, but 6s we did do it a couple weeks ago, so you might be able to remember it. The formula for this is base 1 plus base 2 divided by 2 times height. Now you're thinking, holy smoly, that's a big formula. And it is, but it's not. So if you go back to our original shape, these are two parallel lines. They're not the same length. So we need to find an average or a mean length. So we need to add them together and then divide by 2. And that's what this whole piece of the formula is, to find out what is the mean base. So if this was 10 centimeters and this was 6 centimeters, we would still need also a height here, and our height is going to be 5 centimeters. And again, for area, we don't need the length of these diagonal lines. Okay, so we've got this big complicated formula. This is base 1, the bottom. This is base 2, the top. So I'm going to keep it in brackets, and I'm going to write 10 plus 6 divided by 2 times, and my height is 5. And I'm going to put that in there. And now this might take me a couple of steps. So I'm going to do this side first, and then come to the times 5. So the 10 plus 6 is 16 divided by 2. I can take it out of the brackets now because I only have one number, times 5. So when I look at this, I see, well, 16 divided by 2 times 5 is still a little bit complicated. So I'm going to do the division here. 16 divided by 2 is 8 times 5, because I still haven't done anything with that one. And then I got to squish it in because I like my equal signs all in a row. My answer is 40 centimeters squared. So it's really not that hard. It's just, it looks like a very scary formula because there's more to it and there's one extra step, but it's really not so tough. So let's look at an example here. We're going to draw our trapezoid. Our height, remember it's always the straight uppy downy height, is going to be 3. Our bottom base, we will make 7 centimeters. And we'll make our top, oops, sorry, this is 9 centimeters. And we're going to make our top base 7 centimeters. And again, for area of a trapezoid, we do not need the diagonal. Our formula, bracket, base 1 plus base 2 divided by 2 times h. So you can kind of see how this part of the formula you want to do first, then multiply that part of the answer by h. So let's just plug in the numbers. Step 2. Base 1 is 9 plus base 2 is 7 divided by 2 times my uppy downy height, which is 3. 9 plus 7 is 16. We got that again. Divided by 2 times 3. 16 divided by 2 is 8 times 3. We still haven't used that times 3, so you can see how we just keep bringing it down. And my final answer, if I have room for it, is 24 centimeters squared. We haven't learned how to find an unknown for trapezoids. That we will most definitely leave for another day. So hopefully you can remember all of this review stuff for area. The biggest thing is that you need to be neat and tidy, and you need to leave everything in columns with your equal signs going down, and you need your measurement squared to finish out your answer. All right, talk to you soon. Bye.